Hello everyone, welcome to this video on n queens problem. The n queens problem is a well-known problem in the field of computer science that involves placing n queens on an n cross n chessboard in such a way that no two queens attack each other. Now when do we say that they attack? That is when they are in the same row, same column or same diagonal. This problem was introduced in 1848 by the chess player Max Basel and has since then it's been a popular problem in computer science and mathematics. One of the most popular algorithm used to solve the n queens problem is the backtracking algorithm. The algorithm works by placing the queens one by one on the board and checking if the current placement is safe or not. Again, the safe indicate the constraints. That is, it should not be in the same row, not in the same column, not in diagonal. If the placement is not safe, the algorithm backtracks and tries a different placement. Now we will see how does the n queens problem works. First we start placing a queen on the first row of the chessboard. Then we move to the second row and then try to place the next queen that does not attack the first queen. So we should make sure that when we are placing a queen on the new row, it should not be in a position that it attacks the first queen. We continue this process row by row until we place all the n queens on the board. If at any point we find that we cannot place a queen in a row without it attacking one of the queens that is already existing on the board, we should backtrack to the previous row and try for a new position for that queen. So we continue this process until we have found a valid placement for all the queens. If it is n queens, all the queens, until we have exhausted all possible placement. Now the algorithm for n queens is given here. We use a backtracking technique and there are n queens on and the number of placements available in the board is n cross n. It's an n cross n chessboard. So first and foremost we traverse through all the positions in the chessboard and we find for a particular queen is that position valid or not, which is the best position for that particular queen to be placed on the chessboard. For that we make use of a place algorithm. Now when the place algorithm returns true or false, if it is true we write that position on the board for that particular queen, or and next what we do is we go for the next queen. Now if you have found the position for the first queen, a perfect position using the place algorithm, then we move on to the next queen. So this procedure is continued until all the queens are, we have found position for all the queens. Now the place algorithm, this is a place algorithm. Place algorithm returns true if a queen can be placed on the kth row and the ith column. Otherwise, it will return false. So, in the place algorithm, what basically it does is it is checking whether the queens are in the same column, the already placed queen and the new queen for which position is to be found, is it in the same column or it is in the same diagonal. One thing we are assuming is that we are trying for all possible positions by placing a new queen in a new row, not in the same row. So we are checking for whether they are in the same column or they are in the same diagonal. If not, that is, if we are not finding the position is not in the same column or not in the same diagonal, we say it is true. If it is found in the same column or the same diagonal, we return false. So the return of the place algorithm goes to this algorithm, the major part of the n queens algorithm, and checks if it is true. Then we know that we got a place for the queen, and then we will try for the position for the next queen. Otherwise, uh, we need to backtrack. So this is about n queens problem. So in conclusion, we can say that n queens problem is an interesting problem and the backtracking algorithm is a simple and efficient way to solve the problem. But there are other algorithms that can be used to solve this problem more efficiently for a larger value of n. Yeah. Thank you for watching. I would be very grateful if you could subscribe to the channel. Thank you once again.